It's the day 27 of doing Leetcode daily until I get a job. So let's start with the questions today. Okay, just 1 second. Fine. Can take it here. Perfect. Okay, so I've decided to go with only hard questions from now on because we have done a lot of medium, so we can shift to hards now. So let's have like I sorted it on the basis of difficulty and also acceptance so that we don't like jump onto directly to really hard ones. We'll do the initial hard ones. That is a high acceptance rate. So let's go with this question. We'll skip the locked ones, obviously. We are not going to take the premium version of it. So the first question is unique paths third. You're given with m by an integer array grid where grid ij could be 1. 1 means there is a square and it's the starting square, and there is only exactly one square with value 1. 2 represents the ending square and there is only one ending square. Fine. Now 0 represents the empty squares we can walk over, and minus 1 represents the obstacle that we cannot walk over. So return the number of 4 directional walks from the starting square to the ending square that walk over every non-obstacle square exactly once. Okay, so we have to return number of ways to reach from starting to the ending such that we walk over all the non-empty, so all the empty squares. Okay, if we want to reach from here, it's not like we can reach directly from here to here. We have to cover all the non-obstacle squares, or we have to cover all the empty squares. Then we have to give us the number of 4 directional walks we can have from starting square. Like we'd start from here, we will go this way, then this, then this, and then this. Okay, this is the way of reaching here. Second way can be, it can go like it can go like yeah, it can go like here, 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 that, and that, because we cannot walk over this square. Okay, so there are only two ways we can do this. Either we go this side or we go this side, and then the rest of the path. So there are two ways, so we have to calculate the ways. Okay, so obviously we have done a question similar to this unique path one maybe, and that can be done by DFS, that when we are at any squares, we'll backtrack obviously, but when we are at any square, we will see if it's walkable, if it's valid. If it is, then we will make it visited or something kind of that identifies the visited one, and then go to all the 4 directions, that where can we go and can we from there can we reach the ending position. That we will do by recursion will do its thing. Okay, so firstly we can count the number of empty ways, so that while we are going on our path, every time we walk over an empty one, we will decrement the empty. So what will that do, or we can count the squares we have walked over. If that count is equal to the empty squares, then only it's a path. Otherwise it's not, because we have to walk over every empty square. Fine, this is the condition given. So let's count the empty ones firstly, and let's and one more thing, it's not like the 0 0 is always the starting and the mn is always the end. No, and is here, you can see that. So we have to also find the starting and ending positions here. uh, we have to basically find the starting one. Ending one will be find whenever it's 2, value 2. The square with the value 2 is the ending one. There is only one square like that. Okay, so we can start doing it, and we can start by writing like we'll start iterating this, and I 0 to I less than, let's take int m, m is equal to grid dot size, n is equal to grid 0 dot size. Fine, I is less than m, I plus plus. Then we'll go to the next loop, int j0 to j less than n, j plus plus, and we will see if, firstly we will check, we will search for the starting point. So if grid I j is equal to 1, then is the starting point. Okay, so we can write that, let's take two variables. Yeah, here we can take them, and start I, okay, start I and start j. Fine. So start I will be I and start j will be j. Okay, and what else we need to do here is, if grid I j equal to 0, then we have got empty square, empty plus plus, and let's declare an empty variable in with them empty. Fine. So we have got this. Now we can call the DFS function. Okay, and we will let's say the answer is also declared here. Can we declare it here, or we can pass it through that? Yeah, we can declare it here. Yeah, okay. So how will we call it now? Call the function now is, it will be void function obviously, because we are returning the result at the end. So we will call the function as, what will be inside it? It will contain the grid, it will contain the starting point, it will contain the starting point of ji, and it will contain the steps we have taken. When these steps becomes equal to the empty ones and the value of that square is 2, we have got a path. So currently the steps are 0. So we can now write this function, and it will have obviously this grid, and we will have int I, or we can say r and int c, and int steps, the steps we have taken. So now again, as we do in the rest of the cases, we will just check the validity of these, what do we say, those, I forgot the name, the row number and column number, whatever these are, coordinates. Yeah, coordinates. So x, if x is less than 0, okay, not here. Yeah, if r is less than 0, or c is less than 0, or r is greater or equal to m, perfect, or c is greater or equal to n. What else? Or the point where we are checking is equal to -1, which will be having as the identification for the visited one. If it's -1, we will just return from here. Okay, and if, what is the stopping condition for us? When our steps become equal to count and we are at a square with a value 2, right? So if grid ij is equal to 2, and if steps equals to become the empty squares which we have counted, then we will just do this, rest will be incremented, and again we will just return. Fine. Now we are at a square and we have to, let's make this visited. Okay, let's make this visited. We will do this as -1. If it's already visited, it will be identified here. Okay, let's make this visited and just go to all the 4 directions of it. So we'll call this the function with grid being same, r plus 1 c, and steps been taken 1, so steps plus 1. We can call the same function 4 times in all the directions. Okay, it's grid, not gris. Fine, this +1 goes here. We'll do this -1, and here also -1, and this -1 now goes here. Perfect. Now we have even done this. After that we need to backtrack to, we will just give it what its original value was, and which was obviously 0, because that's why we walked over it. If it was something else, if it was -1 or 2, it will have been the returned, it would have been already returned if it was them. So it must have been 0, that's why we walked over them. Perfect. We'll do this, and now I think that's all. That should do the thing. Okay, grid ij, not ij, man, it's rnc. These things always get me. No matter how hard I try to not get these kind of syntax mistake or the variable mistakes, but they always happen. Yeah, see, they're never gonna stop. Okay, so I guess we did not. Okay, and res is plus here. Starting point we have sent them. Okay, okay, res should be initially 0, and empty ones. Let's run this. Let's see how much we got. Still we got 0. Okay, how many empty ones are there? 3, 4, 7, 8, no. Okay, okay, one more thing. We are walking over this start point, okay. We are considering this in our step, but we are not considering this in our empty ones. So it should be empty plus 1. Okay. Why? Because the empty one is also one step we considered here in the recursion when we get first time we started from here, but the empty one is 1 and it is not considered in empty. Okay, it's only incremented when the value is 0, so 1 was not counted and it should have been. So yeah, we can do it now. Yeah, that worked fine. That was the case, and if now we submit it, we got it with 100% time complexity, and that's a good thing. Let's moving on to the next question again. That is the maximum score words formed by a lattice. Okay, so we are given that a given list of words list is given. Okay, dog, cat, dad, good. List of single letters are also given, and their scores of every character, like array of 26 characters should be. Okay, and they're given the scores of each of the characters, and they, every character has some scores, and they are given letters array also, which consists of some letters might be repeating. So return the maximum score of any valid set of words formed by using the given letters. So in letters का use करके we need to form words which are present in the words vector, and we can form as many words as we can with these letters and calculate the total score. And every letter has a score. Okay, and we need to maximize the score. So here, what can be done is we are at a word. Okay, let's just take a map and count all the letters and their frequency. Okay, like A is coming 2 times, C is coming 1 time, D is coming 3 times, G is coming 1 time, O is coming 2 times. Now with these set of letters, what words can we create? We will go to one by one to each of the word. Okay, we will go to dog. Can it be created with the help of those? Yeah, it can be. We will add the score to our current answer. Okay, then with the remaining letters, can we form cat? If we can, we will. If we can't, we will go to the next letter. might be repeating any sort of or using the given letters. Yeah, we'll go to next. So we will check what words can we form. But the thing is, see, the thing is that let's just say there was one T and that T was used in the first word itself, but it gave a low score. If we use the T in cat, it would have given us a high score. Means we need to go through all the words at least once with all the uh, provided letters. Okay, because if let's say one letter is like utilized in the earlier word, and we do not have any more occurrence of that letter, but if that letter were used in a later word, that could have given us a high score. So we cannot deny that case, right? So we also need to do that. So now what we can do is we can firstly start with creating a map of, yeah, the map of our characters. So the map of character will be an ordered map. An ordered map that will have a character to integer mapping, and for char letter of letters, we will just do this. Okay, we can remove this. MP of this letter will be plus plus incremented. Fine. Now we have the counter of the letters, count of each letter, and let's just say and score is 0 for now. So what we will do is we will call a function, and obviously that will be a recursive call inside that function whenever invalid words we have encountered. Okay, otherwise we can go on and do the things. So we will just call a function, let's say a helper function. It will consist of this map, the index of the words we are at, and the current score, which is starting from 0. So index is also 0. We are starting from 0, and we will have the words, we will have the score, and what more we would have? Do we have the letters? I don't think we'll need letters, right? We have the map of it, so we don't need it. And we will just return the score. Yeah, we will pass score here. Fine, let's write to the function now. It will be a void helper function, a map here, that is this, by reference, perfectly fine. Then index and score, then the words and the score will remove this. We can remove the letters. Okay, fine. Now in this function we will stop when the index is equal to word dot size. We have iterated in all the words. We will just return in that case. Fine. Then we have the map. Okay, we will use the map here. But the thing is, okay, I have a concern regarding map here, but let's deal with it later. Now firstly, what will be it? We will be iterating through the word I. Okay, so int word will be word I, which we'll be considering in this iteration. We should do this here. Okay, So word we need to encounter, we have words I, and we have the word, we have the, let's take current score or the word score for this word. We will calculate it. How will we calculate is that we will go inside each character of this word, okay, and we will check if map of this word is greater than 0, means it has any occurrence, has any frequency left or not. If it has, then we will increase and will decrease that frequency, decrement this by 1, and we will add the score of this letter to the current score, okay. And else if it's not, then let's just take a flag here, bool flag, which is initially true, and we found a letter which is not existing in the map. We will just make the flag as false. Now if the flag is false, we have gone through it, we have gone through this for loop. If we come out and see that the flag is false, then yeah, if the flag is false, then we need to do what? We need to go to next index and check, and but the il- if the flag is, if the flag is true, we'll just go to next index, correct? We will just call this function helper with the map. The index will be incremented by 1, next word we will see, and the score will be what? The score plus current score, fine. And the words will be here and the score will be here. Okay, score is already a vector, so we cannot take score, we can take total score, fine. Control C and okay, yeah, here also we can do it here, fine. We do this, okay, if only the flag is true. But what if the flag is false? As valid is true, then we do this. If the flag is false, we are not even adding this current score to the final score, we will just go on, okay, checking the next words, checking the next word, checking the next words. But I have a problem here is, uh, the problem is with map here, that let's just say we got our original map here, we are using it here, and let's just say we are using it one by one, we are decrementing it, we use this for this word. Okay, 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 okay. Okay, one thing, guys. We need to have a for loop here, right? We are we are traversing the words. Like if the this word for this word is fine, we will go to next word. Okay, there is no loop for that. So we will start our idx is equal to I to itx is less than words dot size then I plus plus. Okay, we will do this idx plus plus obviously, and we will have all this. Okay, up to where? Up to, I guess, the whole function. Yeah, up to here we will be here in this and we'll do this. Okay, so now my problem arises that If this word is fine and this is a valid word, if this is a valid word, then it will go to next counter. Properly good. No problem is here. But if this word is not valid, means we got the flag as false, that we cannot go with this word, we have to go for the next word. Then this map should be again reinitialized to what it was originally. Okay, the same map cannot be used again. So we will, so in case it's invalid, we need to redo this whole thing. We need to redo this minus minus because we are not taking this word. Fine. Like this. We have a cat here. Okay. We cannot C and A because T is not even there. It cannot be formed. So we will, why will we waste C and A on this if we don't have T? So we will just make this like, we'll have a temporary map, unordered map, char int. We will have a temporary map here, and which will be, let's just say temp, and it will be equal to our map. Okay, and we will send the temp here. Whatever we have used, we will send in the next index. But if we haven't used, if this is, if the flag is false and this the word is not valid, we cannot afford to do this. Okay, and this will be doing in temp. This will be doing in temp only. Okay, in temp we do this, we check this, we minus this. If this is valid, it will go to the next function call with the temp, with the remaining letters. With the remaining letters, we have used something and we will, whatever unused, we will go forward with that function call. Okay, but we have used some things, but the word is not even valid. So why will we waste those used ones? We will get them again by comparing it with this, by again initializing the temporary map, and we will, I think this will work fine. So we do this. We have added the total score to current. We have got a total score here. We are not adding a total score if the word is not valid because there is not a score for that. Okay, we need to have a complete word, not just a part of it or prefix of it. Okay, word I, no, it's not word I, it will be words I. Okay, int word, oh, not int word, it's a string, man. It will be a string. So if we run it now, again, current plus is equal to score of C. Score of C. Score of C minus, it should be this. Because score for integers, not for the sky values. Okay, we have got a wrong answer here, which is output is going to be 0, but it should be 23. Fine. So, um, oh yeah, one more thing we need to do is we need to update our score, right? We need to update our score here. Total score we have. See, let's just declare it globally because we have to at every function call or iteration we have to compare it with the current score and update it if it's maximum or more than the previous current score. So we'll just take it from here, write it down here, and we will send the initial score as 0, and it will be the current score. Fine, and we will do this to here, current score में add करेंगे, and at every iteration what we will do is, even before returning, we will see if the total score is increased or not. So max will be max of total score, or the second thing is the current score, and then we will return the total score here. Perfect. Again, it's giving 10. Okay, it's giving 10. So total score is compared with this current score maximized. If index is word dot size, I is word dot size, we will just return. Otherwise, I will be starting from index will be starting from I is the current index. Index is less than words dot size, and index plus plus. Perfect. We will replicate this map, and our current score will be 0 for this word. Flag will be true. String will be word size. Okay. For this word size, we will go to each character. If it is existing in the temp, then we will decrement its counter and add this to the current score. Current score plus score C minus A. Perfect. Else we will flag this as false. Okay. We will break here. Perfect. We will break here. Because if we are not breaking here, somehow that won't make a difference anyways. But no, it will make somehow. Maybe it will, maybe it won't. We don't know. Let's try running this. Again, we will try to debug it. Yeah, it won't make a difference because if the flag is false, it will remain false and it will go to the next iteration. And for the next iteration, obviously it will be revamped to map again. So it will be temp the map current score plus the score of this word is current CURR. CURR will be added in the current score. Fine. And we will send these two here. Okay, we'll start with map index 0 and current score 0. Fine. Map of total score will be maximum of the total score and current score. Fine. Let's see what we got here. If cout we do, what we need to do is let's firstly print the word. Fine. Then we will give a space. Then we will check the boolean value for it, flag. Then we will give a space, and then we will check the word score for it, that is current. That will be all for us. Let's just see if the things are put at the right place. We'll get to know only by this. Fine. So what we got here is dog. It's perfectly fine. We have got 10 score. Cat. Okay, 10 10 ही क्यों आ रहा है ये बस. Is the score 10 for this? DOG. D के लिए क्या है 5 है स्कोर. A के लिए क्या है 1 है 6. G के लिए 3 है 6 और 3 9 9 आना चाहिए ना. Why is it giving 10 here? C minus A. Score of C minus A. What the hell? And it's calling again. Cat, 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 cat. Fine. What we can do for this is if the current score is okay, what score plus is score of this. What do we have it here, man? Can we do this? C out of current and space and score of C minus A. Let's see what we get here. Fine, we got a 5. From where the hell is this 5? Okay, current becomes 5. Score was 5. What's the 5? Oh, D is 5. Okay. Then O comes. O has a 2. 5 to 7. Okay, okay. Dog, for dog it's fine. 10. 10. 10, 10, 10. Fine, 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 fine. Dog 1, 10. Now comes this cat. C 9. Fine. A 10, 1. Okay. Then again we don't get anything. We don't get anything, right? We don't get anything, so after this it will fail. Count 0, 10. We got this word, then it should carry forward, right? And it is not carry forwarding it. If we get the word right, D O G, it should go to the next index and it should carry forward the current score here, but it is not. It is not. Okay, the thing is, I guess I got it right. If the current score is carrying forward, like if we are getting 10 from here, so if we get the C right, it's 9, 1. Okay, 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 fine for this. Now again, we will start from, if this cat is not included now, we will start with the dead. Okay, DAD. Why are we starting again with the cat? Okay, the cat is done now. If the cat is invalid, flag will be false and we will be starting with the next word. We will just break out of this. Okay, we will start with the next word. It's again a cat is coming and it should not be a cat. Okay, okay, I got it. It should be words of IDX, man. What the hell? Oh, that was a silly mistake. Well, it should be good now. Shit, man. Yeah, it's good. So we can remove the C outs. We are good here. Perfectly fine. We'll submit it. We got a wrong answer. And we got a 63 for this test case. We got 51. We'll use this test case and let's see where the hell is this error. What's wrong here? What's wrong here? What's wrong here? Hmm. We got everything good. We start with 0. We have an index then. Let's start with that index. And we will. Okay. So A is coming 4 times. B is coming 4 times. C is coming 5 times. D is coming 3 times. So if ADD is done, DDA cannot be done because they will collectively have 4 Ds. A is fine. There are 4 A's and there are 4 A's in total. There are 4 B's and there are 3 B's. Fine, that is also fine. C's are 5 and we don't even need any C's. So the problem is with D only. We have 3 D's and these two words surely can be done. Now out of these 3 CDs, only one can be done. We have a add twice. Fine. So just again, let's have this things, only this one, and run this test case on it. So what we got here is add, ठीक है हो गया 121, डी ए नहीं हो पाया तो फिर हम बी बी पे चले गए, डी डी ए नहीं हो पाया ना भाई, डी डी ए नहीं हो पाया तो बी बी पे गए, बी बी हो गया 18 आ गया, बी बी फिर से हो गया, व्हाट, वाई, बी बी is done one time, why is it coming again? we'll have the current score when we whenever we got flag as true. Wait, I got it. I got it. It should be this index plus 1. The recursion call should be this index plus 1, not I plus 1. I is the current one. Okay, we know that. We'll just go forward with this I in this loop. If the word is valid, then we'll go to the next word. If we ADD is valid, we go to DDA, and DDA is valid, invalid, then we go to BB. But if DDA is invalid, we'll go to BB. Fine. But if BB is valid, then we should go to BAA. It is coming again to BB because DDA was the I. That's where the problem is. I think I got it. Let's run this. Fine, this is good now. Let's see, it should submit now. A lot of problems always already has been there. Fine. So these were the two hard questions, guys, and we did it really good. Okay, we are fine. Okay, that's good. And I guess that will be it for today. We got these two good questions, two hard questions. So that's it, guys. Let's meet on D28.